那我第一眼那个差不多要注意一下。
让我他们扫的很小。
又加入了。
Okay, good afternoon, everyone. Today, what we are talking about is buffer solution. Does everybody remember the last class? We talked about weak acid and its conjugated base, and weak base and their conjugated acid, like CH3COH and CH3CO-. And now, today our lesson is buffer solution. So buffer solution, what is buffer solution? What is buffer solution? Does everyone have any opinion or have any thinking about it? Give you some interest to organism, like human body or animals. Organism will die if the pH variation, we have a big variation in pH. So that's very dangerous. If we drink Coca-Cola or we drink some carbonated drink, will you pass away if you drink those drinks? Like Steve Jobs, like Tom Cruise, when they drink Coca-Cola, they pass away?
No.
Of course not. So why? It's because of buffer solution. There's something in our human body can beat acid, have the capacity to beat acid or base. So let's look at the video.
There's still water in both glasses at the moment. I'm going to add universal indicator.
Okay, this video have demonstrated unbuffered and the buffer solution. On the left-hand side, unbuffered is just water. So, and the right-hand side is buffer. It will add some substance into this uncomposed buffer, and he will add indicator. Did anyone have memory of indicator when we are talking about acid and base? We said in different pH. pH is in different hydronium environment or concentration. In different pH, the indicator will have different color. So we can know about this solution's pH by the color. So the indicator can tell us which color it is. So let's look at it. On the left-hand side, we put some indicator in the unbuffered.
And the color indicates pH. So a green color.
And right-hand side, we also put an indicator into it. So in pH 7, it's green.
These have the same color because I haven't added anything other than water. And now I'm going to add a buffer to this glass. The buffer I'm using will make the pH certified 7.00 plus or minus 0.2 pH.
So the teacher added the buffer into the components into the buffer. So on the right-hand side is buffer solution. And the teacher is going to add some HCl. HCl is strong acid, you know? And NaOH is strong base. The teacher is going to add some strong acid into both of the solution, unbuffered and the buffer. Let's observe what will happen.
And it's conjugate base. That will make the pH be 7.00. Very similar color to what we used. That indicates the distilled water also has a pH very close to 7.00. Now I'm ready to challenge these solutions with acid and base.
So we drop one drop of HCl into both of buffer and unbuffered. What's happened? The color changed into red. If you are on buffer, you add one acid, you add one strong acid into the buffer. The color from green and change to red. Green pH is 708 and red is 203. So it means it will have a big variation if you add acid or base into a buffer. And let's look at buffer.
Change the color, and we're down way down around pH 2.
And now he's going to add acid into the buffer. 1, 2, and 2 drops. Did the color change? No, the color didn't change.
Buffer solution is still at very close to pH 7.
So it's still in pH 7.
So titration here where I add drops to store.
4, 5, 6. Add lots of this. Did the color have changed apparently? No, it's just changed into 8 to 7. It's not have a big change. Almost 50 drop, and it's only pH 7 to pH 6 color. So you see what's different between unbuffer and buffer if we drop some acid into the solution. What's different between these? The unbuffer's color change have a big variation or doesn't have a big variation. If we put a drop of HCl into a buffer, the color change, yes, it has a big variation. But buffer, we put lots of acid into the buffer solution. Does the color have a apparently change? No, so it means our buffer will have a big pH variation if we add some acid or base into the solution. But buffer, even though we put lots of acid or base into the buffer solution, it doesn't have a big pH variation. And now let's look at if we put some base into the both buffer and the buffer. So now the teacher puts NaOH, strong base, into the buffer. Let's look what's happened. Quickly turn to another color.
Greenish color, bluish green color.
pH 2 red and to pH 7 green. And one more drop. Turn into blue or purple, pH 11. So if you are not buffer solution, you add some acid or base. Only add a little into this. The pH will have big variation, but then look at buffer solution. Also add lots of into this, finally change color. So after watching the video, what did you observe? What did you observe? You found that if we add some acid, if we one drop of acid into a buffer, the color change apparently. But if we add into the buffer solution, did the color change? No. We add lots of it, it's finally changed. So can you tell me what's the definition of buffer solution? You can speak it in Chinese or English.
The buffer solution consists of a weak acid and is conjugated base.
Very good, but that's not a definition. So the definition is if you add some acid or base, if you add acid or base into a buffer, the pH will have a big variation. You have seen on the video.
Yes.
The color. But if today you add some acid or base into buffer solution, there is only a little variation in pH. The color didn't change apparently. So, and now we are going to talking about what the classmates said. The buffer is composed of weak acid and its conjugated base, like 0.1 molarity CH3COOH and 0.1 CH3CO minus, weak acid and its conjugated base. So let's have an exercise. What's buffer? Question for the following is buffer solution. A, HF and NaF. Is HF weak acid or strong acid? It's weak acid. So, is this buffer solution? Weak acid and its conjugated base. Yeah, so it's buffer solution. And B, HCl is strong or weak? Strong acid. So it's conjugated base. So is B buffer solution? No. And C, NH3 is weak base. So NH4Cl is conjugated acid is buffer or buffer? Buffer. Buffer solution is composed of weak acid and its conjugated base, or weak base with their conjugated acid. And D is the answer of why when we drink carbonated drink or we drink Coca-Cola, we won't pass away. Because in our blood we have buffer solution. And our blood's buffer solution is composed of H2CO3 and NaHCO3, weak acid and its conjugated base. So D is also buffer. And then E, HNO3 is strong acid. So is this buffer? No, strong acid and its conjugated base could not compose buffer. So after the exercise, now we are going to tell you about the principles of buffer solution. So let's look at the blackboard. Let's talk about the principle of buffer solution. So I thought all of you have some question. Why weak acid and its conjugated base can compose buffer solution, but why strong acid and its conjugated base could not? Today, if we have a weak acid, HA, its Ka is very little. So now, if we have a buffer composed of HA and its conjugated base A minus, maybe 0.1 molarity. So what would happen if we add some acid into the solution? This is buffer solution. If we add some acid into the solution, acid can give hydronium. So, what would react with hydronium? Acid can react with base. So, HA is weak acid. It cannot react with hydronium. But A minus is HA conjugated base. So conjugated base can react with hydronium and form HA. So the concentration of hydronium will not be large because A minus can react with what we add in hydronium, what acid we add. So the hydronium will not in a big concentration. And if today we add some base into the buffer solution, base have hydroxide ion. Hydroxide ion can react with A minus or HA. Which of it? Base can react with acid. So hydroxide ion cannot react with A minus, but it can react with weak acid HA. So HA reacts with hydroxide ion. And hydroxide ion react with the hydronium from water. So can formate A minus and water. So why the buffer is composed of weak acid and its conjugated base? Because if you add some acid into the solution, the conjugated base can react with acid, so the hydronium will not in a big concentration. And both, if we add some base into the solution, base can react with weak acid, so the concentration of hydroxide ion will not in a big concentration. So let's look at if today the solution is composed of HCl, strong acid, and NaCl. Let's see what would happen. We all know about that HCl is strong acid, so it will dissociate into hydronium and Cl minus. And both NaCl can also dissociate into Na plus and Cl minus. So the solution only have hydronium, Cl minus, and Na plus. If today we add some hydronium into the solution, does any of the substance can react with hydronium? Hydronium can react with base. Hydronium, no. Cl minus, it's not base and it's not acid. Na plus also. So add hydronium, add acid into the solution. There's no substance can react with acid. So the concentration of hydronium would rise. So the pH will have a big variation. And today, if we add some base into the solution, hydroxide ion can react with hydronium and form water. So because of hydronium can react with hydroxide ion, so the concentration of hydronium will decline, or you say decrease. So the pH will have a big variation. So that's the principle of why buffer solution is composed of weak acid and its conjugated base, but not strong acid with their conjugated base. Because weak acid can react with base. Weak acid conjugated base can react with acid. But strong acid cannot react with acid. Strong acid, hydronium react with hydroxide ion. So there's no substance can have the buffer capacity. So this is the principle of why strong acid and its conjugated base cannot be buffer solution. So let's look at the PowerPoint. We have told about it on the blackboard. We have a buffer solution composed of weak acid and its conjugated base. If we add acid into the solution, conjugated base can react with acid, and form HA. So the hydronium will react with it, and the concentration of the hydronium will not have a big variation. And if we add some base into the buffer solution, weak acid react with hydroxide ion and form A- and water. So hydroxide ion can react with weak acid. So the concentration of hydronium or hydroxide ion will be not in a large concentration. So it will not have a big variation in pH. Everybody understand? And the last, why strong acid and conjugated base cannot be buffered. We have talked about it. So now, let's have some exercise. Give you 2 minutes to discuss about it. Please tell me the definition of buffer solution and give me some example of buffer solution. So, discuss about it. What is the definition of buffer solution? Definition.
The definition of the buffer solution is a solution that can resist pH change upon the addition of an acid or basic component.
Very good. Oh. The solution that can resist acid or base is buffer solution. So the solution won't have a big variation in pH. And give me some example. What's buffer solution?
Ammonia and ammonium chloride.
Very good. Ammonia, NH3, is weak base. So its conjugated acid, NH4 plus, is weak acid. So the buffer solution is composed of weak acid and their conjugated base, or weak base with their conjugated acid. The next exercise. We have told you about our blood composed of H2CO3 and HCO3 minus. So this is a buffer solution also composed of two of it. And now if we add some acid into the buffer and we add some base into the buffer, which substance will react with acid? Or you say react with hydronium. Which substance will react with hydroxide ion? So if we add some acid into the buffer, you think HCO3 minus or H2CO3 will react with buffer, will react with hydronium.
HCO3 minus.
Very good. Hydronium is acid, so it can react with base. H2CO3 is weak acid, and HCO3 minus is its conjugated base. So hydronium react with HCO3 minus and form H2CO3. So which substance will react with base, hydroxide ion? Which of it? H2CO3 or HCO3 minus?
H2CO3.
Very good. Hydroxide ion is base, so it can react with weak acid H2CO3 and form water and HCO3 minus. So the last one, give you 3 minutes. Please give me the answer. There are 6 solutions. Please tell me which of the solution can be buffer. You can tell me in Chinese or tell me in English. It's all okay. It's all no problem. So, is the first one buffer? First.
Yes.
It's buffer. Na2HPO4 is weak acid. And Na3PO4 is its conjugated base, so it's buffer. And is the second one buffer solution?
No.
HCl is strong acid. So strong acid and their conjugated base cannot be buffered. 3. NaOH and Na plus. NaOH is strong base. So Na plus is conjugated acid. It's also not buffer because buffer is composed of weak base and their conjugated acid, not strong base or acid. And number 4, HCOOH and HCOO-Na. HCOOH is weak or strong acid?
Weak.
Weak acid. So its conjugated base can form buffer solution.
Yes.
So 4 is also. And number 5, HBr is like HCl is strong acid. So is it buffer?
No.
No. And the last one, H2S and NaHS. H2S is weak acid, so it's buffer because weak acid and its conjugated base. Okay. We have one to talk about buffer capacity. Let's just look at a video. In different concentration, different buffer solution will have different buffer capacity. Let's just look at a video and then we will finish our last class.
Grammarly does more than catch errors. With Grammarly,
now, on the left-hand side is water, and in the middle is 0.1 molarity of buffer, and in the left-hand side is 1 molarity of buffer. Let's look at the difference if we add some acid into the solution. So we put strong acid into it. Quickly change its color. So a buffer. So we put 4 or 5 drops into it. It finally changed color. It's also put 4 to 5 drops into the solution. But did the color change? The color didn't change. So different concentration have different buffer capacity. If the concentration of the buffer is more large, it will have a great capacity to resist acid or base. But if the concentration of the buffer is not larger than the other, it will have a lower buffer capacity to resist acid or base in the medium. So this is the last what I'm going to talk you about, the buffer capacity. So the last 4 points, please tell me. Which of the following concentration of buffer solution has stronger buffer capacity? First one or the second one? Yeah, the first one. Because the concentration of HCOH and HCOO-NA is bigger than the second one. So have the more concentration, have the great buffer capacity to resist acid or base. So today our lesson is finished. And the next class I'm talking about is the calculation of the buffer. We're going to calculate the hydronium or the pH of the buffer solution when we add some acid or base into the buffer. So thank you everybody.